All right, good afternoon, everybody. Welcome. My name is Anthony Sneed, right here. And this is the Securing Web APIs the New Way with OWIN and Katana. So it's nice to see everybody. I know I got a few tweets, so I knew there were at least 3 people coming. I'm glad there's even more. So if you are not on Twitter, we need to have a talk after the workshop. But beside that, you can monitor a lot of what we're doing in this session as well as my session tomorrow by going to Twitter. And this is because the sole purpose of my time here is to increase my Twitter presence. All right? And so I've created a hashtag called DW Web API Security. Right? And you can open up Twitter and go there. And from there, you should be able to get everything else you need or would like to have, hopefully, for this workshop. We're going to start with my blog, which I believe is right here. It's blog.tonysneed.com. I blog on various security topics, Web API, and a bunch of other things as well. So you can go there to see what I'm talking about. The slides will be available, of course, to everybody in the conference. I've also placed them in a Dropbox, so you can have early access to the slides for this talk, as well as for the one tomorrow. It's bit.ly/Web API Security. And lastly, the code, all right? And that's some of the most valuable things to get from a workshop. I put that on GitHub, all right? And you can get it there. So you can go to github.com/TonySneed/Web API Security.demos. And that's also linked to from Twitter. Okay, so going there, you should be able to get everything you need for the workshop. All right. Okay, so to begin with, this is, well, let me go through a little bit of introduction about myself. I am married with 3 children between the ages of 4 and 9. I started out living in Southern California, Los Angeles, moved to Dallas, and now I'm living in Slovakia. It's a long story. We'll have to talk about it some other time. But that's where I live now because my wife is Slovak, and we have parents and family, etc. That's where I'm living. I do most of my work for a company called Wintellect, and founded by a fellow named Jeffrey Richter and Jeff Procyse and John Robbins. And there I work both as a consultant and an instructor. I've also worked as an instructor for other training companies over the years, and I've been to London many times working for that company. I've also got a set of training videos. The website is wintellectnow.com. And I'm going to be putting up there a series of videos on Web API. I've already got a whole series on Entity Framework, which I'm going to talk about tomorrow as well. But Web API material is coming, so you can go there to get that. And I can also tweet out a promotional code for you. Okay, so you can get a couple of weeks free trial. I've also got 2 open source toolkits. One is called Simple MVVM Toolkit. This is when, if you were anybody, you had to have your own MVVM toolkit, right? Otherwise, you weren't anybody in the Silverlight space, at the time. So I have one of those. I also have another open source thing called Trackable Entities. If you're coming tomorrow, you'll hear more about both of those, because that's what we're going to be talking about, is Entity Framework, MVVM, Web API, and a whole assortment of topics. Let me get a couple of hands here. Who's going to tomorrow's workshop? Anybody? A few people? Okay, maybe more by the end, hopefully. All right, this is how you can reach me. Email, old-fashioned, and all sorts of social media. And again, if you get the slides from the Dropbox, bit.ly/Web API Security, you can then get these slides and have this information. This is also the information about the code. So I encourage you to look at the code along if you like, even during the presentation. And Dropbox, and there's the Twitter and hashtag. I may need to apologize if I cough. Okay, I'm speaking softer. I apologize in advance. Okay. The new way. Okay, I'd like to start out with an apology. The title of this talk, Web API Security, is completely wrong. So I have a little bit of bad news for you. Starting with the next version of ASP.NET, there will be no Web API Security. In fact, starting with this version, the bad news is, with OWIN and Katana, security is taken out of Web API. Okay? The good news is I'm going to be telling you all about that. So don't fear, we do have something to talk about. And not only that, but we're going to talk about how you can architect and build Web API services today that will be forward compatible with the next version of ASP.NET. Okay? So the news is ASP.NET is unifying MVC and Web API. So strictly speaking, Web API is kind of going away in a sense as a separate product, and it's being merged into ASP.NET. Right? So we have a lot to look forward to, and my goal here today is to help you make that transition, right? So you don't go out and build Web API services based on this old model, this old paradigm, right? And you're in with the new way of doing things. So we're going to talk about OWIN and Katana. vNext is conceptually compatible with OWIN and Katana. It's not based on OWIN and Katana, but it is based on the same ideas, the same architecture. So how you build your application and your services layer, how you model that with OWIN and Katana will be identical to how you're going to do it with vNext. Okay? So you're going to be in a very good position to go forward. Right? The main theme here is host and framework independence. Okay? That's what the whole idea behind the new way of doing things is. So I'm going to show you, talk about that. I'm going to show you the big picture of Web API security, which is going to include a lot of things. You know, security is a kind of thing where you have to make sure you cover all your bases, right? So if you leave something unsecure, then you're unsecure, right? So I'm going to show you the big picture of Web API security. That's going to include, you know, basic HTTP security, right? And one of my goals is to hopefully help you become more friendly with just HTTP security. And it's relevant because Web API is simply a programmatic way to do HTTP services. Okay, it's all about HTTP, right? So we'll look at that. So we'll start with the transport security, the nuts and bolts. I'm going to show you some tools, some very practical demos of how to implement SSL, not only for IIS, but also for, you know, any kind of .NET application, an NT service, for example. And you're going to want to know how to do that because, like we said, we're host independent. And lastly, we're going to take a look at authentication middleware called Katana. And this is where you're able to apply a security model for authentication primarily, also for authorization, but we're going to focus on authentication, in which you are not only decoupled from the host, from, you know, the web server or the Windows server, whatever it may be, and the underlying framework, you're also decoupled from the web framework, right? So you could use Web API or you could use something else, right? You could use Nancy, you could use some other open source web server of some kind. You could even use various other kinds of things. So you're independent, but there is a Web API piece to that, which you're going to need to know about in order to call back into the middleware. Right? So we're going to talk about that whole mechanism and how it works. All right? So the old way, handcuffs. Right? I had a talk with the organizer of the conference and said, you know, it's a problem because the advanced topics are coming after the introductory topics, and he says, well, you have to be loosely coupled. Okay, thank you. And that's really what this is all about. The old way is tightly coupled. Security is tightly coupled, okay? And it's coupled to the host. It's coupled to also the underlying framework that you're building on top of. And Web API is symptomatic of this because you have two kind of hosting models for Web API. You've got web hosting, and you have what they call self-hosting, right? N-tier services, for example, or NT services or Windows services. And depending on how you host, you are then built either on WCF in terms of self-hosting or ASP.NET if you're hosting in a web application. And then how you do security is going to be entirely different, right? Depending on how you're hosting everything, right? If you're self-hosting, you're going to have to be WCF bound, right? And you're going to need to configure security in the WCF bindings, right? That kind of thing. And otherwise, you're going to be bound to ASP.NET. And so you're going to need to do this kind of thing, and it creates problems, especially when you have mixed applications. So one of the motivations for this new model is not only independence from the host, but also independence from downstream frameworks, right? It's very common to mix technologies in a single web application. For example, I might be doing MVC, web pages, web API, Signal R, right? All in one application, and I don't want to have to implement security 4 different ways. Right? I want to implement it in the middle, where it can then apply downstream to any kind of services, right? And that's what this whole new vision is about. All right. So before I get on to the new way, let me take a survey. How many people in here are currently doing Web API? Oh, good, you're in the right place. All right. And I'm assuming I don't have to spend a whole introduction on Web API for you, which is good. How many are doing Web API 2, the latest version? Right? How many people are currently using OWIN? A few of you. Okay, good. We'll make converts out of the rest. All right. Anybody take a look at vNext, ASP.NET 5, MVC 6, I've had the privilege of actually contributing to it. It's on GitHub, so they let anybody, submit a pull request, and so they got about 2 weeks of free labor from me, right? So I'm familiar with vNext, right? So I'm going to try to give you what you need to make that transition, and that leads us to the new way, okay? In case you're wondering, this is a Fruit Ninja. And this is where the word katana comes from, right? The blade used by a samurai, right? Now, there's a reason for that. That's because the goal is to separate things out, right? So something came along called the OWIN specification. It's not a Microsoft spec. It's just an open source specification. And the idea behind it is to decouple web applications from the host, right? And to decouple yourself also from the downstream web framework, and anything you want to apply as a cross-cutting concern is going to go in the middle, right? So OWIN simply specified an interface, right, which is simply a pointer to the next component in the chain of middleware components, right? And passing along that chain is simply a dictionary of environmental variables, right? And so it's a very simple model, very simple specification. Microsoft's implementation of OWIN in this current day is called Katana, right? And the primary thing that you find in Katana is authentication middleware, security. And it turns out security is kind of the driver for this whole Katana idea, because it's the kind of thing you want to apply in the middle as a set of middleware components, because you don't want to be coupled to the underlying host. You don't want to be coupled to the downstream frameworks. Right? So this is the conceptual basis for vNext. vNext is not using OWIN itself, but it's exactly the same concepts, the same architecture. Right? So let me interrupt myself and say that if you have questions, feel free to interrupt. Okay, I'll take them as we go along, and raise your hand or whatever, and I'll be happy to entertain your questions. okay, as we go. All right? Yes?
Just like ADFS, where do they come in all this? I'm just getting slightly confused with all the different mechanisms that's out there. So where does ADFS fit in with all this? Katana and OWIN and all that type of stuff?
So the question is, where does ADFS fit into all of this? And interestingly enough, ADFS and Kerberos and that kind of thing is simply a security token service. So its job in life is simply to give out a security token, right? So essentially, the role here is that the middleware component is simply going to go out to that service, get the token, right, and then send it to the consuming service. Yeah, and so that's one thing to keep in mind. Mm-hmm. Yeah, so it's just another kind of security token service. It issues SAML tokens, it issues JSON web tokens, everything that can be understood. Yeah. All right. So let's talk about the big picture, and we'll look at the whole entire landscape of security that you need to concern yourself with as a developer. Right? Now, developers are notorious for, let's say, not paying a whole lot of attention to security, right? Let's just get that right out there, right? It's kind of an inconvenience, we have to secure this thing. So as a result, a lot of us are just illiterate, when it comes to security, and it's such a broad landscape, right? And there's so many moving parts, and it's changing, I did no less than 3 consulting services based on security models, and they changed radically from one to the other as we're moving now to different models, right? Just a few years ago it was SAML, right? Now it's JSON web tokens and OAuth, and So I'm a firm believer in just bringing you up to where we are now and giving you some guidance so that you can be prevented from going back and using old technologies, okay? When there's newer things around that are better. Right? All right, so let's talk about the various components in this picture. First of all, we have the client, and in terms of web API, that's going to be usually HTTP client. It could be a browser as well, right? And on the client, we have something called a message handler that allows you to specify client credentials, that allows you to validate the server certificate. And next, the client is going to be communicating over some sort of transport. This is going to be HTTP, okay, in today's world. When we talk about HTTP, we have to become familiar with HTTPS, TLS, SSL, and X509. And lastly, we're going to be communicating with some sort of host that usually falls into these 2 categories, either a web host or a self-host. Okay? And web is either going to be IIS, or it can be, communicating with IIS either using the ASP.NET model or something referred to as Project Helios, which allows you to communicate with the host with IIS, but without going through ASP.NET. Okay, so which is great because system.web is 10 years old. A lot of overhead, and it's expensive when you have a large framework that you're bringing into your memory and you're paying for cloud services, right? So the goal here is to not only be decoupled from IIS, but also from ASP, right? And that's what we see going forward. So the first element of security is something we call confidentiality. This is where you talk about something like encryption, you're guarding against eavesdropping, and so you're basically securing the communication such that no one can read the messages. Integrity is the next component. This is where you're going to sign the message. Essentially, you're going to prevent tampering, man in the middle, replay attacks, things of that sort, message integrity. And then finally, authentication, in which you're going to do 2 kinds of authentication. One is to authenticate the server to the client, and the other is to authenticate the client to the server. Both are important, okay, and we're going to talk about both of these. This is where Kerberos comes in. That could be one way of authenticating client certificates, some sort of a shared secret, a token-based service such as JSON web tokens. So what do you notice about this chart? Where is most of the security taking place? the transport level, right? Which is interesting because you'd think that, well, we're doing security, we have to do all of this at the application layer, right? Or at some other layer. But it turns out we're doing it at the transport level, right? And we're doing authentication. Server authentication takes place here. The pipe is secured in terms of both encryption and privacy, right? So one of the goals here is going to sort of enable you to be able to do authentication at this level. So we've got a few minutes we're going to spend at the beginning just looking at just basic HTTP configuration. Let me take a survey so I know how much time to spend on it. How many people are really comfortable with SSL? That's what I thought. Okay, and the people raising their hand are doing very timidly. They don't want anybody else to see them, so they'll ask you questions. Right? And that's about what I usually get, right? And so I'm going to one of the goals is to help you to be more comfortable with it, because anything else that you do in security with authentication and OAuth and all of these things, JSON Web Tokens and SAML, none of that matters if you don't get this level, right? So this is sort of a prerequisite, right? If we continue to the next layer, this is where OWIN fits in. This is where we have authentication middleware. This is essentially where we're now authenticating the client to the server. We also have something called claims transformation, in which you can inject things like roles, right, attributes to users in order to make authorization decisions, right? Those are usually application specific, right? And so there's a hook where you can inject application specific claims. So the user of your application has a privilege to spend a credit limit of £1 million, for example, right? But no more, right? And you can attach those kinds of things to the user and make these decisions. Then in the web API layer, you have two things, authentication filters and authorization filters. We're not going to talk about authorization in this talk, but I will point you to resources because we just don't have time. But I'll point you to resources where you can learn more. Okay? We're primarily going to focus on authentication. And you'll notice a little arrow between authentication filters and OWIN Katana middleware, right? Which implies that we're really not doing authentication here in Web API at all, right? So if you're doing that, stop, right? If you're writing message handlers and things to do authentication, don't do that. You want to move your authentication to the middle layer, right? You want to write authentication middleware, and you can do that pretty easily in Katana because you just have a set of base classes, you extend them, and I'll show you how to do that, okay? Okay, so, and then you make these kinds of decisions, okay? Right? And that's where authentication is going to take place, in the middle, right? So this is in the middle where you're going to be requesting tokens either from ADFS or some sort of certificate server, okay? Or doing some sort of authentication, right? And then authorization is domain specific, so that'll take place right here, okay? In your framework. And that's where the authorization filters come in. And this makes sense because this is specific to your domain. Right? It's not a cross-cutting concern necessarily. All right, any questions so far on the big picture? All right. Okay, so let's talk about transport security, securing the pipeline. All right. It's not required to laugh, don't worry. All right. But out of courtesy, I would appreciate it. All right, let's talk about securing HTTP. So let me just throw out a question. Is HTTP secure? No. There's absolutely no concept of security in HTTP. They simply punted that. And essentially what you have to do is do security at the transport layer. Right? We call this TLS, transport layer security, otherwise known as SSL. And I just use the terms interchangeably. So essentially, that's what this formula means. If you're doing HTTPS, you're doing security not at the protocol layer, HTTP, but at the transport layer, okay? That's because HTTP has no built-in security. TLS and SSL provide encryption, guarantees against tampering, replay detection, and some sort of authentication via X509 certificates. Okay? So I'll hopefully familiarize you with some terms as we go along here. Right? So that's how we're going to secure the pipe. And we get all of this confidentiality, integrity, and authentication right here thanks to our certificates. Okay, let's talk about certificates. Who can tell me what does an X509 certificate give you? Right, and a private key and a public key, and how are they related? You just have to read the slide, but you know, it makes me feel like you know something. Yeah, so yeah, if you encrypt with one, you can only decrypt with the other, right? Asymmetric encryption. Can anybody tell me, is asymmetric encryption used with SSL? Of course, yes. But is it used to encrypt the entire message? No, why not? Pardon?
Too slow.
Performance, exactly, it's too slow. Yes, a question in the back. Did you have? No, we're just acknowledging. Yeah, exactly, performance, right? So it's simply used to encrypt an exchange of keys, and those symmetric keys are then used for symmetric encryption for the rest of the conversation, right? So you have this handshake. So it's strong, but expensive, okay? And you kind of have to keep that in mind. And so oftentimes you see this pattern. All right, so in terms of encryption, you're encrypting with the public key, right? So that the owner of the private key can decrypt, right? And that also provides something interesting, which we'll talk about in a minute. A mechanism, if you do this in reverse, for digitally signing the message. In other words, guaranteeing against, or trying to mitigate is a better word, in case someone wants to sue me or something. We're going to mitigate the risk of someone tampering with the message, right? And in that case, we sign the message with a private key, right? And not the message, but we sign a hash of the message, right? Meaning we encrypt the hash, right? And it can only be decrypted with the public key, right? So essentially, it's a simplification, but that's basically the concept at a high level, okay? Any questions? No? Okay, so I mentioned server authentication a couple times. And so this is the first authentication you need to be concerned about. Is the client talking to the right server? Okay, a lot of times we don't think about that. We think of authenticating the client to the server, but it's just as important to authenticate the server to the client, right? And this is what, you know, this certificate is all about, right? And because the certificate has a number of properties. One of those is the common name, right? And in order for a certificate to be valid, the host name of the request needs to match the common name of the certificate of the server that is receiving this request. Okay? So that's where you see the green lock as opposed to the red line, okay, or various other symbols, right? And it's very important. So the client needs to validate the identity of the server, right? And it does this, right? And there's all kinds of problems here, as you know, right? You know, fake servers out there, and you know, fake certificates, social engineering. You know, someone calls up Microsoft and says, you know, I'd like to order a certificate, please. You know, here's the information, and then they can pretend to be Microsoft, right? And so that's a big problem. So part of this server authentication is checking a certificate revocation list, right? And that can be online, and you can check to see, okay, are there any certificates that are considered invalid because we know that they've been spoofed, okay? Right? So server authentication. And this will be also important when it comes to your own certificates, which I'm going to show you how to create. You're going to need to pay attention to this common name, okay, in order to make sure you have a valid certificate. So when you set up the cert, you have to think about that, right? So to trust a server certificate, I mentioned there is the need to not be on the certificate revocation list. But the other thing is that it's issued by a trusted root certificate authority. You guys familiar with this? Right? You've seen this, right? So, okay, so you've got a Windows certificate store, local computer, or current user, and the issuer of that certificate somewhere in the chain needs to have a trusted root. Right? And if it doesn't, then you're in trouble. And trusted root means simply the certificate of the CA is in the trusted root certification authorities. Right? Anybody issue your own certificates with Windows Server? Right? Yeah, okay, 1% in the back. Certificate, it has a built-in certificate authority, and you don't have to pay for certificates if you're in a staging environment or something. You can just create your own, right? Yeah, it's pretty common. And then for developers, there's a test certificate as well, okay, which we'll talk about. So I can create one of these. I can create a certificate for development purposes just by going to IIS Manager, and there I can create a certificate called a self-signed certificate, okay? And that self-signed certificate can be used for development purposes. So it's both the certificate authority and the certificate itself, right? And then the other thing you can do is request certificates and complete a certificate request, right? So you can do all of that through IIS Manager. Okay. And then what you end up doing is usually copying the self-signed certificate to the Trusted Root Certificate Authority in your Windows Certificate Store. Okay. Then we have MakeCert. How many people have used MakeCert? Just a bunch of you. Okay, how many have abused it? No, you don't have to raise your hand. Okay, so MakeCert's easy. The thing about it is it's got a lot of command line arguments. So I'm going to provide you with a batch file that lets you create your own development certificates without much trouble. So you can find that in the GitHub repository. And for that, I have to give a shout out to Dominic Baer, who created the batch file for me, right? And made that available to all of us. So thank you, Dominic. So this is the idea behind MakeCert. You execute this command, you get your own certificate, and there's a little message saying that it's not trusted. You need to somehow trust it. Now, most of the time, we'll maybe just copy the certificate into the trusted root, but there's a better way to do that. This is just an explanation of some of the parameters for MakeCert for creating a self-signed certificate. Okay, and this can be more convenient. You can also specify parameters, validity parameters, and other kinds of things. And then next is creating the certificate authorities certificate, right? So you want to create two certificates using MakeCert. One is what I'm calling DevRoot. It's simply the issuer of this MakeCert, essentially, issuer of the development certificate, okay? Okay, so you can kind of use these in conjunction with each other, these two batch files, essentially, create the DevRoot certificate, and then create the development certificate such that it's issued by the DevRoot, okay? So it's a little bit more realistic in terms of having two certificates, one for the CA and one for your server, okay? And there's more parameters there, and this is the one you're going to copy to your trusted root, okay? I'm going to just pay attention to my time here, okay. All right, and this has a lot of parameters, so you're going to really appreciate the batch file. Okay? Okay. Secondly, once you've generated the certificates, you want to bind them to either IIS or to some sort of self-hosted web API service, right? An NT service, even a console app, okay? And that's how you're going to do it. So you're going to need to know the certificate common name, because that has to match the binding, okay? Right? So, for example, if we issue ourselves a certificate that's called web.local, I create a binding in IIS where the host name is web.local, okay? So that the certificate is properly validated, okay? And that's how we do that, okay? So that it matches. So you have to pay attention to that. And then secondly, in a development environment, you're going to want to probably edit the host file so that the loopback address points to your host that you just created, web.local. Okay? And you're going to find that in this Windows directory, system32 drivers, etc. How many people have messed with that? Yeah, quite a few. Okay, so we won't spend any time on that. And it's one of the things you have to do. So here's some information for you to know how to do that. And then once you get to Visual Studio, you simply set the project to local IIS, and you make sure that that host name is there with HTTPS. Okay? Okay. And then your certificates will be valid. Right? right? And then how do you set up those bindings? Well, you're going to use a tool called NetSH. How many people use NetSH? A couple? Okay. The brave ones. You run it as administrator, and then you're going to do some URL reservations. In other words, the process that's running your application needs permission to register a URL with the kernel level HTTP driver. Okay, and so you need this tool to do that. And here's the command. Commands you're going to find it with NetSH. There's an HTTP section, and you've got show, add, and delete. And here's an example of making a URL reservation. Right? So the second you get this access denied error when you try to run your service in a self-host, you can make the reservation using this command line. Okay? Or you can use a GUI. Okay, which I prefer. That's called HTTP config. You can download it from Steve's techspot.com, right? And that's a very convenient tool, right? And that's also on the GitHub site that I downloaded it for you, right? So you can get this tool, and you can use it both to make URL reservations under the permissions tab as well as SSL bindings. Okay. So this is how you would use it to do a certificate binding. So if I have a self-hosted web service, I'm hosting in a Windows service or something like that, then I want to use this tool to make that reservation. And there's certain parameters, and I'll show you how to do that. Okay, all right? So you can use the GUI to do that, okay, or the command line. Okay, and then lastly, a little slide here on how I do this with OWIN, right? An interesting thing about OWIN, when I create a web API service with OWIN middleware, you're going to set it up differently, much differently than you would, the standard Visual Studio template, for a web application, right? It's much simpler, easier to do. But the interesting thing about it is that self-hosting does not rely on WCF, okay? Anybody use WCF here? Quite a few people, okay. Hate to tell you this, but WCF is like going the way of Windows Forms or something. It's not really the thing that Microsoft really cares about now. They care more about the web, which is why we're here. But the liability was in Web API, you were still using WCF if you were self-hosting. Right? Well, that goes away, and instead, if you're self-hosting now, you're simply using HTTP listener. Okay, so it's a very simple model, right? There's no plumbing underneath, okay? And so you simply specify, an HTTPS schema, right? And that's how you configure an OWIN host, self-host, right? To use SSL, okay? So that's this, right? And now I have a demo, right? Any questions before I go on? Okay, I'm going to show you how to do some of this certificate setting up. And let's put that down here. Okay, here's my tools folder. I'm going to get the magnifying glass. There we go. All right, so I can go in. There we go. So we're going to be doing these. Again, this is on the GitHub site, so go ahead and just, you can execute these commands. This is the HTTP config. And these two batch files use these other executables, make cert, and the private key. Okay, so you're going to need that one too. And okay, so what we're going to do is go here. The other thing I'll point out is I have a set of demos up there. They're Visual Studio solutions. They contain a set of step-by-step instructions for replicating what I'm doing now. Okay, so you'll have a before solution and an after solution, and simply follow the steps. Okay, so you'll have something to go back to. Okay, so we're going to start out here real quick, and I've already added the NuGet packages, so we don't have to wait for that. And you simply add two of them. For an OWIN application, self-host and OWIN self-host, okay? Those are the two ones, and those I've already added. Let's go ahead and add a controller, all right? All I've got is a program main. It's a console app, all right? Okay, halfway through. So let's go ahead and add a class file. Try that one. There we go. Code. And we're going to call this, what did I say? Customer controller, something like that. Here we go back here. Back to the README. Yeah, oh, hello controller. Okay, so let's do hello controller. And we'll add a controller. So you can see you can host Web API in any host. It doesn't have to be hosted by IIS, which I think is really interesting because the last consulting job I did, they said the reason they're using WCF is because they don't want to host in IIS. Well, you don't have to with Web API. You can host, you can self-host, right? It can be a Windows service. So let's do this here. Okay, you're going to need to derive from API controller, which is right there. Let's get rid of that. Okay, this is how we create a web API. And to speed this along, I'm simply going to copy and paste. A very simple get action. Just returns a string, hello web API self-host. Right? Next thing is this idea of a startup class. Right? So this is really fundamental, and this is something that is going to really go forward, okay, in the next version of ASP.NET, the startup class. This is equivalent to global ASAX. Right? The difference is that you don't have to be hosting on IIS for it. Right? You can use any host, as we said. So we just call it startup. It's by convention. Right? And what we're going to do is add a method to it called a configuration method. So I'm going to go back here and just copy and paste. And you'll see what I'm pasting in here is kind of interesting. This configuration method is where you set up the middleware, right, that you're asking OWIN to use. Right? So, and the order matters. Right, and as I mentioned, the idea behind OWIN and Katana is a series of middleware components, each with a link to the next component. Right, so the one at the end, this welcome page, is the endpoint essentially. Right, it's like a handler, right, in ASP.NET, and anything before is going to service whatever comes after. Okay, and so this is where we're going to end up putting our security. Right? Right? And all I'm doing here is simply configuring it for Web API. Notice the extension method off of App Builder, use Web API. Right? And this exact same syntax is what we see going forward into the next version. Right? There's also a welcome page, which just gives you a nice, something to look at. Right? Right? So, and then in program main, we're going to get it going with this piece of code here, using block webapp.start. And we should be able to launch it. All right, so there it is. And you'll see here, it's simply using localhost, and I'm just picking an arbitrary URL, right? 54321, doesn't matter what it is. I'm going to hit Control F5. It's going to launch the self-hosted web application. It's listening on that port that I specified, right? So once that's started, I should be able to go back here and open up a browser. I'm going to use IE. I feel sad for it, so I'm using it. There you go. And so here's the welcome page. Okay? Nice. Okay, and then what about our controller? So we routed API/hello. Right? Hang on. That's the problem with memory in a browser history. It wanted to use SSL. And so I'll go ahead and open this, and you'll see I've got a very nice JSON string. Okay, so the default is simply to return JSON like we'd expect. Okay? So this is all unsecure. How do we then secure it? Okay, that's the next thing. Okay, so one thing we can do here is we're going to go ahead and do some certificate things here, right? And then we're going to set this whole thing up to use transport security. So I've got a snap-in already set up for certificates, so I'll just open that up. This is the local machine. What we're going to end up doing here is simply going ahead and executing these command lines. that we talked about, creating some certificates, putting them in the store, okay? So I'm starting out without anything but localhost there, and the trusted root certificates does not have devroot in it yet. So I'm going to go back here, and I'm going to do the create devroot command. So let's go back and do that, okay? I'm going to go up here and say, I'm using a nice command line tool called Commander. I highly recommend it. You can check the blog if you want some information on that. I need an elevated prompt, so I'm going to create one. All right. And now I'm going to, oh, it didn't even, well, there goes my command here. So let's go back. And I'm going to go ahead and just copy that. Paste it there. And I'll just for convenience, I'll do a path to the tools folder. Okay. Okay. All right. And I'll just execute the command lines, the batch files. Okay. So the first batch file is called create dev root. Okay. Like every good developer, I'm going to leave this completely wide open. There it is, if it'll let me. There we go. Okay. Yes, of course. All right. And so I've got a nice certificate there in my certificates folder. Let's go ahead and do the other one, which I believe is this one right here. It's called, okay, we're going to do all that. Yeah, okay, so before we create the next one, let's go ahead and just copy that certificate into the certificate folder. So you'll notice here I've got a PFX, and I can just double click it and I'll install it on local machine. Elevate. Let's grab that. No password. And let's go ahead and place it in the trusted root, certification authorities. All right, so it's there. And, you can go back and look at it, but I'll just move on here. The second thing we're going to want to do is edit our host file. And we're going to want to add this line that maps the port address, the loopback port address to web.local. And I just so happen to have that open. And I'll paste it in. And there we go. Save it and close it. So now if I use the loopback address, it's going to map to the web.local port name, or host name rather. And now I'm going to go ahead and do the other thing as well. Okay, so let me see if I did the other one. Okay, here it is. There's another one here called create SSL cert. Let me do that from my command prompt. And I'm going to specify the host name, web.local. Okay, and I'm going to grab that. I'm going to copy it to the other one. So let's go ahead and install that one. Here we'll just say current user and automatically detect. Okay, all right, so they're both there now, and we should be able to refresh and see those. Okay. Oh, did I? Oh, hang on. Do it again. Local machine. Let's try that. Okay, that's what I wanted. I'm glad I looked. Okay, so there it is. If I look at localhost, you'll see that it's got a private key associated with the certificate, and it shows me the certification path is there as well. Okay, so that should be okay. That's localhost. I didn't want localhost. I wanted devroot. Oh, well, I'll just copy it there. But it's usually not recommended. So dev, let me refresh this one. All right, devroot is there. So I'm happy about that. But I didn't see localhost. I mean, I did see localhost, but I didn't see web.local. Oh, maybe because I didn't double click it? Okay, you guys are supposed to let me know when I'm making mistakes. That's participation. Okay, now it should be there. All right, there it is. Web.local, that's the one I'm looking for. Certification path, as you can see, is right there, dev root. Okay, so everything's set up now, hopefully, and we'll go on. And now the next part is to give ourselves permission. Now, it turns out that the local user is the account under which this console app is running, right? So I've got to give the local user, myself, permission to register a URL using this certificate. So we're going to do that with our HTTP config tool. This is going to be easy to do because it's GUI. Okay. And here it is. So I go to the permissions. I can see the existing permissions. I can go ahead and add a new permission. Now, the key here is going to be the URL, right? So I'm going to, like every good developer, copy and paste. And the difference is I'm going to make this web.local. And I'm going to make it HTTPS. Okay? And you have to include the trailing /. So we go back here to HTTP config. We're going to add a permission. I'm going to enter the URL. Let's see if I can, that's better, right? Zoom in. And now I get to add myself. All right, so I'll simply type my name, check name, and you see I have register permission, right, for that URL. Oops, zoom out and click OK. There we go. Okay, so I've added the permission, and that'll keep me from getting this this error, this access denied error. I also need to add an SSL binding. Okay, this gets a little more interesting because the address is going to be 0000. The port is going to be 54321. I'm going to click New to create a random GUID, and I'm going to browse to the certificate that I want to bind, which happens to be web local. Okay. All right, and click OK. All right, so now I've got a very nice binding. All right, are you with me? Okay, so something you can, replicate these steps on your own, and click OK at the end. All right, and so now I should be, in theory, able to press Control F5. Shall I? Drum roll. Yes. Okay. So it started. Wait a minute. Don't celebrate yet. Go back here. Change this to HTTPS. Incidentally, if I hit HTTP, it's going to complain now because I'm not running under HTTP anymore. Right? So I'm just going to escape from that. It's just spinning. HTTPS. Now notice here, I'm getting this problem. Why is that? Yeah. It's just seeing if you're awake, that's all. Web.local. All right. There you go. Ta-da. And let's go ahead and do web.local /API hello. Okay. And sure enough, we have our JSON. All right. Okay. All right. So let's, oops, that's a link there. All right, so that's what we have here. Let's end that. Any questions?
You installed the certificates 3 times.
Yes, that was called human error. Actually, 2 times was the correct number. Yes, the first was to install the dev root certificate authority certificate. Yeah, that's the certificate that is said to have issued the web local certificate, right? So web local is what I'm using to secure the channel, right? That's the SSL certificate, right? But that guy has to be issued by a certificate authority that is trusted, right? It's the CA certificate that we're calling devroot, and that's what I put in the trusted root. Make sense, right? So the issuer of the SSL cert goes in devroot. Okay, so I had 2 certificates. And should have been twice. I copied localhost there by mistake, I think. So it was really twice. All right, any other questions? Okay, so let's see how we're doing here. Okay, so we are over halfway through. Now it's for the exciting part. How about that? Okay, we've done with the boring kind of, transport security. Now we're going to talk about Katana. Okay, and for that we need Uma Thurman. Okay, right? And this is all about authentication with Katana. We're going to slice up the web app, and you'll see here, as I've demonstrated in the demo, right? The OWIN middleware, which is Web API, is just a piece of OWIN middleware, right? That's all it is. It happens to be a terminating middleware component, so it issues a response, but it goes in the middle. So Web API isn't even, really down here. It's just another middleware component. I can also put in there MVC, Signal R, any kind of other web framework, and the authentication is going to go right here in the middle, and the hosting framework can be independent, okay? Right, the only thing that's not really supported is WCF, okay? So that really shouldn't be there, right? And so how OWIN works is we have this chain of middleware components, right? Each one's got a link to the next component, and there's this environment dictionary. And this is what you're going to see in Microsoft's Katana project. This is the strongly typed wrapper for the OWIN specification, okay? So there's a base class called OWIN middleware. You inherit from that. You get a constructor which accepts the next middleware component, and your job in life in this invoke method is to call invoke on the next component in the chain, okay? And this allows you to do pre-processing and post-processing, okay, on that request, right? And this is exactly how authentication is going to work. And so to build this middleware chain, you're going to need to do this in the startup class, and we saw this earlier with Web API. If you had your own custom middleware component, it would be inserted right here before the Web API, okay? Because this is the end. This is going to give us the response. If I want to do something, this is similar to an HTTP module where I might do some processing on the message as it goes through the pipeline, right? For example, this could be a logging component, right? And essentially, that's where we're going to put our security, okay? So let me just explain the nuts and bolts of how the security negotiation takes place. There's really two method calls, right? The first is what we call a challenge response, okay? In other words, the client requests access to a service. This request is anonymous. The user is not authenticated. Therefore, the server returns a 401 unauthorized response. Okay, we're all familiar with that. But in addition, there is a header called www.authenticate, right? This header is really important because it kind of gives the client a hint as to how to authenticate, right? And part of that information is what we call the realm, right? This can be an application identifier, a GUID, a URL. It's usually a URL of some kind that uniquely identifies your application, right? So that this client knows how to authenticate to you, okay? The kind of authentication that you need, right? And then there's a scheme which indicates the authentication type. And this is either going to be basic or typically bearer if you're using OAuth tokens, right? So once the user decides they want to authenticate, they'll authenticate, send some credentials, right? Those travel in the, which header? Authorization, right? So authorization header. Anybody do Windows Identity Foundation or SAML? Good, you haven't been corrupted, that's good. But everything took place, the SAML assertion, everything was stuffed into this header, right? So obviously it was too big, so you had all this, these challenges, but that's still where it goes, right? So any kind of credentials go in the authorization header, and you get back either a 200 or 401, right? Yes? What's 01? That's called a typo. Should be 200, thank you. And, all right, just put it on Twitter and embarrass me, please. All right. Okay, so now the moment we've all been waiting for, Katana authentication middleware, okay, the actual heart of our topic. And this is based on a set of abstract base classes, right? The first one is what we call authentication middleware, abstract base class, right? This has a create handler method, okay? The handler is what's going to be doing the authentication. Now, to create one of these, the middleware component, and by the way, that is exactly what I'm going to inform OWIN about, is this middleware component. To create one, I'm going to want to pass an authentication options class that's going to contain the type, basic, Windows, this is where, Kerberos might come in. You can do client certificates if you want, X509, whatever kind of authentication you want to do, right? OAuth, whatever it happens to be. The mode, active or passive, and we're going to learn more about that later. And finally, other kinds of options. Usually the realm is going to be there, this kind of thing you want to pass back to the client in the challenge. And maybe a validator, how you're going to do the validation. Right? That's optional. So what happens here is the middleware creates the handler. The handler's job is to authenticate, and that's why we have authenticate core async. There's some initialization, teardown, and there's this guy here, apply response challenge async. So you have control over the response challenge as well, and like inserting the realm right into the response challenge, right? So the client has contextual information, right? And then finally, what we get at the end is this thing called an authentication ticket, which has a claims identity and a set of authentication properties. Right? Who here is familiar with claims identity? Claims. It's good. It's very encouraging. Okay. Claims is a new way to talk about identity. It's simply attributes of some entity, right? Usually maybe a user, for example, right? So their age, whether they have a driver's license, and you can make authorization decisions based on things. The one takeaway I'll give you with this part is get used to not thinking about roles. Okay, roles are one kind of claim that you can attach to a user, but it's very limited. It's binary, right? You can get a much richer basis for authentication and authorization by claims. Okay, so you get back a claim set, and as of .NET 4.5, this is just baked into .NET. Okay, claims identity. So you get one back. Okay. So the options is here. This is what the options class might look like. And what I'm going to do here is I'm going to show you an example of basic authentication. Right? Now, as soon as I finish showing you this example, I'm going to tell you not to do it. Okay, I'm going to tell you how bad it is. Don't do it. I know you're going to do it anyway, so I'm going to give you what you need to do it. But more importantly, joking aside, it's going to show you how the components work and fit together and interact. Okay, it's kind of the best way to learn. Because when you get to OAuth, you're going to use the same set of base classes. Okay, so any kind of authentication is exactly like this. So we're just using this as an example. And you can see here I've got a constructor. I added this myself. It takes a realm. It takes a validator, which is just a delegate to a method that returns Boolean given a username and password. And then I expose that as those two as properties on this thing. Okay, my options. Right, so I'm passing a pointer to a method that's going to validate the user. Got it? And then in this guy, the authentication middleware, it's strongly typed. The type argument is going to be your options class, right? And then you're going to go ahead and return. You're going to override create handler, and you're going to return a ticket. Okay. And so this, you're going to return an authentication handler, a concrete handler. And that's this next class, basic authentication handler. Okay. And here you're going to override this authenticate core async as well as the other method. But in here is where you're going to do your authentication, and this is where this is where we get into authenticating the user. So we're going to look at the authorization header here, right? We're going to pull the credentials out, username and password. We're going to decode them, all right? Because they're just basically encoded plain text. And then what I'm going to do is going to this slide, take the username and password from the authorization header, and then pass it to my validator, right? My validator method. Okay, so here, try get credentials is just a little helper method which decodes the username and password. Here, I pass these username and password to the validator, and the validator will look up the user credentials, validate the user. Okay, in a database or something like that, right? And then once the user's validated, notice this is asynchronous. I just new up a claims identity, pass in the claims and the authentication type and return it. Okay, makes sense? So it's good to know how this plumbing works, right? And I pass the claims identity to the ticket and we're golden. Okay. All right. So this is a very simple version of the building blocks. Okay. Any questions? Okay. Usually when you see these middleware components, it's common to create an extension method as a convenience for use in the configuration method of your setup class. Okay, and so this is that. Okay, so I usually have a method like use X, right? So we'll create one called use basic authentication. It'll accept the realm, it'll accept the validator, and then the options. Okay. And then I'll return it as well. So this is the extension method. And in my startup, I simply say use basic authentication. Pass in the realm, pass in my validator. Okay? Okay. This is the demo on this. I am going to show you the after. Because there's no point in, going through this lengthy demo, running out of time, and telling you not to do it. But the code is up there, and you can have a look at it. Okay? And basic authentication, and you can see that in action. Now the reason I don't want you to do basic authentication is because the potential for exposing the credentials is high. Okay, all right, it's just a bad idea. All right. First of all, you have to send the username and password on every request, which means the client needs to store it securely. You need to secure the pipe, which, now you have no excuse, You're going to have to do that. But the problem is also, not only does the client have to store it securely, but the server has to validate it on every request, trying to defend against brute force attacks, and it's computationally intensive. And, you have to do a lot to do this in a hardened way, right? And you're going to fall short doing that. So the danger sign is here flashing. Okay, so don't do basic authentication. What we want is token-based authentication. Okay, and this is where we externalize the whole authentication process from the application. So as an application developer, you should not be concerned with authentication. Right? You don't have to reinvent that wheel over and over again, do it a slightly different way than every other application, right? You externalize it, and you have a token service, right? And its job in life is to validate the user credentials, issue a security token, right? So a lot of that, those components go into, instead of going into your application, like what we just saw with basic authentication, it goes into the token service, right? Right? And then the client can cache the token. It has an expiration. The token is encrypted, right? It's also MAC, so there's defense against, man-in-the-middle attacks and replay and all of that. So it's secure. It's fairly secure, and right. And so this is what that looks like. Okay, so the credentials are sent to the token service, sent back to the user. The client can cache it, send it into the relying party. So this is another term you'll learn. Relying party is what accepts the security token, validates it with a trust relationship with the token service. Okay, so it knows that this token came from a trusted issuer, and there you go. And this is exactly how Active Directory works in Kerberos. It's the same model, right? And that's what you want to do there. And so I'm going to show you how to do that. So there's built-in support for this for OAuth, right? OAuth is kind of the cool kid on the block. We have version 2, and there's a class called OAuth Authorization Server Provider. You simply validate the user credentials and issue the security token. And so here it's an abstract class, so you override this method here. You can call it your validator. Remember the validator? You've got one here. This is within the token service. Okay? So you create a separate web API service just to issue tokens. All right, that's the takeaway here. And then you can validate those credentials. You can issue the claims identity. The key here is they don't have to be every time the user wants to invoke the service, your business service, it doesn't have to re-authenticate, right? And because the token's encrypted, et cetera, it's hardened. And in addition, you can also use SSL security, which you're going to want to do. Okay? So this is basically how you do this. Now, I'm going to tell you likewise, again, to try not to do this yourself in a real application. Again, I'm showing you a model of how it works so that you can then go to some third-party, real authorization server and use that, right? And the one I'm going to plug is, anybody use any out there? And I'll plug one or two. Anybody use any security token services? ADFS, of course, but let's say you've got external partners or a public-facing service. There's one called Ping Federated, right? That's a commercial one. And my favorite is, which I'll promote, is ThinkTexture Identity Server. Okay? It's open source, it's free, and it's got a great following. It's on the Microsoft Foundation server. So don't create your own except for understanding how it works. Okay, so you should create your own, look at the demo code, and then and even use it as a proof of concept. It's fine. Okay, but when it comes to real applications, there's lots of things that you have to do to set up that trust relationship and things, and there's no need to reinvent that wheel. Okay. Okay? But you've got the basic architecture. We're putting this component in the middle. We're calling to the token service, and we're allowing it to validate the user, right? So in my startup class, in my token service, I'm going to specify this use method. I'm going to pass in some properties to an options class, right? So the same exact pattern as we saw before. And I'm going to specify a provider, right? And this provider is something you're going to implement. And I'm passing it the validation method. And this is what the options class looks like, or the startup class, rather, for the relying party. So once you've set up the server, and you see it's just a trivial amount of code, right? Then you set up the client to be able to accept OAuth bearer tokens, and a bearer token is basically the default token in OAuth. And then you use it as a middleware component. Okay? So every request coming into my Hello World service here is going to be authenticated using a token provided by my token service. Make sense? Questions? Yeah. Okay. Let's show you what that looks like. Before I do, I want to just wrap this part up, which is where does Web API fit into this picture, right? As I mentioned, this is almost a misnomer of a talk because security, Web API, security is really taking place in the middleware components. I may host it in a Web API kind of service, but it's really taking place in the middle. Web API really doesn't have anything to do with it. But there is a hook in Web API to be able to apply authentication to specific requests. Okay? And we call that an authentication filter. Right? Now, what you don't want to do is message handlers for security. Don't do that. You can use that message handlers for other cross-cutting concerns in your Web API service. Okay, that's fine. But don't use it for security. You want to use an authentication filter because this is going to play nice with the Katana middleware, and it's also going to allow you to inject application-specific claims. Right? So once you've essentially authenticated the user, right? You then have access to that user on the user property of your API controller. You've got all the claims, and you can say, oh, let me add claims to that for this application. This user I know is a manager or whatever, and then you can make authorization decisions based on that. Okay, make sense? And so that's how you're going to do that, and you're going to do authorization through another set of filters. Okay. So in the Web API pipeline, it looks like this. Message handlers are no longer used. We're going to do authentication filters, both to inject application-specific claims as well as to indicate that certain actions or controllers need to be authenticated. And then when you get to authorization, you'll implement a separate set of filters. Okay. And in order to use these authentication filters, you're going to want to use passive authentication mode. Okay, so there's two modes to authentication in Katana. One is active mode where you're authenticating on every request, right? And it cuts across all downstream services. I guess that's the best way to put it. So if you've got say a mixed application, maybe your MVC application is doing cookie-based authentication, right? For SignalR, you're using maybe something else, and for Web API, you're using OAuth, right? But by placing these things in the middle, you can implement different security mechanisms for different downstream services, or web applications, I should say. So it could be maybe a Nancy application, MVC, or Web API, okay? And for that, we're going to run in passive mode, and this is what you need to do when you're using filters, okay? And then you can also do it globally. There's an attribute, or you can do this globally by suppressing default host authentication, right? So maybe you're in a MVC application that uses cookies. Well, you don't want to use cookies for Web API. You're just locating your Web API in the MVC application, right? In that case, you want to suppress that. It's going to insert a message handler, which does the suppression. And then you're going to want to add filters here. So this is how you do it globally. We're going to add a host authentication filter. This is the concrete default authentication filter. You can just use it, okay? You don't have to create your own. And you pass in an authentication type. Okay? All right, so this is the idea. So one thing is to use it for authentication, to say this particular method needs to be authenticated using, OAuth to bearer authentication, right? This other method needs to use cookie-based authentication. This other method needs to use maybe some external provider like Twitter, right? Right? And so you get that kind of granularity both at the controller and the action level by using a filter attribute. Okay? So this guy here, host authentication filter, is an attribute, and you can apply that on controllers and actions. All right? Okay. And now we have this one here. I'd love to be able to do all of this completely from scratch. I think I'm going to, seeing we're almost out of time, I'm going to have to show you the after. I know, it's kind of a bummer, but here you go. So I happen to have this on Git, so I'll open up my Git folder. And I'll look at source, and here's authentication, and I'll just do this, this one here, token-based authentication. So let's go ahead and open up the after one. Yeah. I forgot I need to open up as a, well, no, actually, I'll do it without elevating. I'll just use IIS Express to begin with. All right. And here you can see I've got a client, I've got a relying party, and I've got my token service. Okay, and the load failed. Oh yes, I know why. Because hang on. I wonder if I can edit this thing. Yeah, hang on. I just have to create the URL. It's just complaining. IIS. Actually, you know what? Hang on, I'm going to elevate it. Yeah, because the after I left off using IIS, right? And as you know, I've got to elevate Visual Studio to use it with IIS. So let's do that. Okay. Then it'll create the virtual directory. Okay. So while it's opening, let's see, any questions so far? How does it sound? Okay.
I think most of it makes sense, but I'm going to review.
You need to review the code and everything, yeah. But conceptually, does it make sense? Okay. All right. We're going through this seismic shift. So going forward, really what you want to do is, use OWIN. Right now, if you're developing any greenfield applications from now on, use the OWIN hosting model, okay? And then we'll go from there. Just a few minutes left. Let me just run this real quick here, and I'm going to. It's just one of these things. Oh no, it doesn't. It's not letting me do that. Hang on. Well, I probably won't be able to fix this in time, but let me just entertain some questions. How about that? And then maybe, maybe in the time we have left, if you want to stick around and watch me actually show the demo, I will. But I just have to fix the project file so that it uses IIS Express, because I haven't set up the. Oh, I know what's the problem is. Okay, I could fix it. I just have to do SSL configuration in IIS, and then it'll open. Okay, so no big deal. So questions? We have 5 minutes. Yes.
So if we use this model that you really showed here, how much will change for VNext?
Okay, very good. So VNext will not use the same set of base classes. You know, the OWIN base classes and OWIN middleware, but the pattern will be exactly the same. Okay, so you will get you'll get middleware classes. They just won't be dependent on OWIN itself because they want to move beyond where OWIN went. Okay, add more features basically. Yeah, but conceptually it's the same. Yeah. Will there be an OWIN implementation of? Yes, the authentication pipeline and things like that. You're saying, yeah, absolutely. Yeah, in fact, and one thing I'll recommend, I'll give a plug to my friend Dominic. If you want to get more information on this topic as well as just security in general, Dominic has got some great Pluralsight courses, and they're in the booth upstairs. Right, so you can check him out on Pluralsight and get more information, right? Any other questions here? Let me just bring up my conclusion, right? All right, so the takeaway here is don't ignore transport security. That was a big one, right? Become familiar with those tools, know how to set it up, because you're not alleviated from doing that. It's even more important that you care about transport security. The OWIN middleware is all about decoupling from the host, from the web frameworks, doing everything in the middle. Katana is Microsoft's first pass at doing this, right? And the next will come in vNext, okay? And so it's a constantly evolving landscape, right? So at least hopefully you know SAML and Windows Identity Foundation doesn't really apply anymore. You need to move toward this new model of doing security, okay? And based on this work that they've done in Katana, right? Right? Any other questions so far? Okay, I think that does it. I will be around here for questions. Am I ending on the right time? Am I? Okay. Sometimes I end like early or late, and but yeah. So come up to me afterward. I'll be happy to help you. And the code for this, as you remember, is all up on GitHub. I'm going to put that slide up for you. And again, ask me questions through Twitter as well if you have any follow-up questions. Okay. And there we go. All right, I think that does it then. Okay, thank you very much, everybody. Is unifying MVC and Web API. So strictly speaking, Web API is kind of going away in a sense as a separate product, and it's being merged into ASP.NET, right? So we have a lot to look forward to, and my goal here today is to help you make that transition, right? So you don't go out and build Web API services based on this old model, this old paradigm, right? And you're in with the new way of doing things. So we're going to talk about OWIN and Katana vNext is conceptually compatible with OWIN and Katana. It's not based on OWIN and Katana, but it is based on the same ideas, the same architecture. So how you build your application and your services layer, how you model that with OWIN and Katana will be identical to how you're going to do it with vNext. Okay? So you're going to be in a very good position to go forward. Right? The main theme here is host and framework independence. Okay? That's what the whole idea behind the new way of doing things is. So I'm going to show you, talk about that. I'm going to show you the big picture of Web API security, which is going to include a lot of things. You know, security is a kind of thing where you have to make sure you cover all your bases, right? So if you leave something unsecure, then you're unsecure, right? So I'm going to show you the big picture of Web API security. That's going to include, you know, basic HTTP security, right? And one of my goals is to hopefully help you become more friendly with just HTTP security. And it's relevant because Web API is simply a programmatic way to do HTTP services. Okay, it's all about HTTP, right? So we'll look at that. So we'll start with the transport security, the nuts and bolts. I'm going to show you some tools, some very practical demos. Email, old-fashioned, and all sorts of social media. And again, if you get the slides from the Dropbox, bit.ly/Web API security, you can then get these slides and have this information. This is also the information about the code. So I encourage you to look at the code along if you like, even during the presentation. And Dropbox, and there's the Twitter and hashtag. I may need to apologize if I cough. Okay, I'm speaking softer. I apologize in advance. Okay. The new way. Okay, I'd like to start out with an apology. The title of this talk, Web API Security, is completely wrong. So I have a little bit of bad news for you. Starting with the next version of ASP.NET, there will be no Web API security. In fact, starting with this version, the bad news is, with OWIN and Katana, security is taken out of Web API. Okay? The good news is I'm going to be telling you all about that. Okay? So don't fear, we do have something to talk about. And not only that, but we're going to talk about how you can architect and build Web API services today that will be forward compatible with the next version of ASP.NET. Okay? So the news is ASP.NET of how to implement SSL, not only for IIS, but also for any kind of .NET application, an NT service, for example. And you're going to want to know how to do that because, like we said, we're host independent. And lastly, we're going to take a look at authentication middleware called Katana. And this is where you're able to apply a security model for authentication primarily, also for authorization, but we're going to focus on authentication, in which you are not only decoupled from the host, from the web server or the Windows server, whatever it may be, and the underlying framework, you're also decoupled from the web framework, right? So you could use Web API, or you could use something else, right? You could use Nancy, you could use some other open source web server of some kind. You could even use various other kinds of things. So you're independent, but there is a Web API piece to that, which you're going to need to know about in order to call back into the middleware. Right? So we're going to talk about that whole mechanism and how it works. All right? So the old way, handcuffs. Right? I had a talk with the organizer of the conference and said, it's a problem because the advanced topics are coming, after the introductory topics, and he says, well, you have to be loosely coupled. Okay, thank you. And that's really what this is all about. The old way is tightly coupled. Security is tightly coupled, okay? And it's coupled to the host. It's coupled to also the underlying framework that you're building on top of. And Web API is symptomatic of this because you have two kind of hosting models for Web API. You've got web hosting, and you have what they call self-hosting, right? N-tier services, for example, or NT services or Windows services. And depending on how you host, you are then built either on WCF. All right. Okay, so to begin with, this is, let me go through a little bit of information, introduction about myself. I am married with 3 children between the ages of 4 and 9. I started out living in Southern California, Los Angeles, moved to Dallas, and now I'm living in Slovakia. It's a long story. We'll have to talk about it some other time. But that's where I live now because my wife is Slovak, and we have parents and family, etc. That's where I'm living. I do most of my work for a company called Wintellect, and founded by a fellow named Jeffrey Richter and Jeff Procyse and John Robbins. And there I work both as a consultant and an instructor. I've also worked as an instructor for other training companies over the years, and I've been to London, many times working for that company. I've also got a set of training videos. At the website is wintellectnow.com, and I'm going to be putting up there a series of videos on Web API. I've already got a whole series on Entity Framework, which I'm going to talk about tomorrow as well. But Web API material is coming, so you can go there to get that, and I can also tweet out a promotional code for you, okay? So you can get a couple of weeks free trial. I've also got 2 open source toolkits. One is called Simple MVVM Toolkit. This is when, if you were anybody, you had to have your own MVVM toolkit, right? Otherwise, you weren't anybody in the Silverlight space, at the time. So I have one of those. I also have another open source thing called Trackable Entities. If you're coming tomorrow, you'll hear more about both of those, because that's what we're going to be talking about, is Entity Framework, MVVM, Web API, and a whole assortment of topics. Let me get a couple of hands here. Who's going to tomorrow's workshop? Anybody? A few people? Okay, maybe more by the end, hopefully. All right, this is how you can reach. All right, good afternoon, everybody. Welcome. My name is Anthony Sneed, right here. And this is the Securing Web APIs the New Way with OWIN and Katana. So it's nice to see everybody. I know I got a few tweets, so I knew that there were at least 3 people coming. I'm glad there's even more. So if you are not on Twitter, we need to have a talk after the workshop. But beside that, you can monitor a lot of what we're doing in this session as well as my session tomorrow by going to Twitter. And this is because the sole purpose of my time here is to increase my Twitter presence. All right? And so I've created a hashtag called DW Web API Security, right? And you can open up Twitter and go there. And from there, you should be able to get everything else you need or would like to have, hopefully, for this workshop. We're going to start with my blog, which I believe is right here. It's blog.tonysneed.com. I blog on various security topics, Web API, and a bunch of other things as well. So you can go there to see what I'm talking about. The slides will be available, of course, to everybody in the conference. I've also placed them in a Dropbox, so you can have early access to the slides for this talk, as well as for the one tomorrow. It's bit.ly/Web API Security. And lastly, the code. all right? And that's some of the most valuable things to get from a workshop. I put that on GitHub, all right, and you can get it there. So you can go to github.com/TonySneed/webapi security.demos, and that's also linked to from Twitter. Okay, so going there, you should be able to get everything you need for the workshop.